Greetings, everyone. The homework for separating variables, 2.4. We have two types. And I gave a homework problem. I'll solve a problem from each of one. And in the review for the quiz, I do the same. And the quiz will be also one of the two types. So the first type is what we call Bernoulli. Bernoulli. And so how does it look like? The general equation is, what happened here? I don't know what this is. Oh, this, I see. This is something that has to go cut. Okay, Bernoulli. It's of the form y prime plus px equals y equals fx. This would be a linear one, so the Bernoulli is the only difference with the linear one. It keeps giving me this. Is this extra term here that you would have. Okay, and that's the form we have. Well, okay, there's an x in front of y prime. So this is something you have to always on the lookout for. Each form has a standard form, and they might be sometimes different. When you see, for instance, exact equations that we discussed in the lecture today, you see that, again, the shape is different, and that's, if you can put it in that particular shape, it is of the form. So the question is, can I put the original equation into the shape of the Bernoulli? And that is, of course, clear by dividing each of the terms by x. So there's 1 over x here, let me write that, equals x cubed y to the 4th. And so now it is much clearer that we are dealing with the Bernoulli. Okay, yes. So step 1. Let's, what we need to do is use find the complementary homogeneous equation. That would be y prime plus 1 over x y equals 0. And what we want is some solution. So I'm saying here that you see that very often now we've done several techniques. You see very often we do an auxiliary thing, we solve from an equation, and then we do a variation with parameters with the u. And sometimes we need the general one from the first and the particular one from the second, and sometimes it's just the other way around. Okay, that might be a little bit confusing, and so that's why each method has its own ingredients. So in this one we need some solution. Okay, let's do that. We know that these homogeneous linear equations are always separating variables. That's now the terminology that we have been using, so let's call it that way. So of course divide both sides here by y, and you see how the variables now are separated. And it is sometimes better to write it with the dy y equals dx over x, and then we're going to take integrals of this thing, integration, sorry. So that would be ln of y equals ln of x plus c. But remember, some solution, so the plus c is not necessary. No need for the plus c. Okay, so this is an empty space that I'm pointing at because we don't need that. Okay, and now because that makes it very simple to solve that c that y is x. So now step 2 is now we need the general solution using the parameter u. Y is u times whatever it is that we found here. This, in this case, is just x, but this could be much more complicated. Okay, so that is the general solution that we're going to try to find. But of course, we have to take into account that y depends on x, so it has a derivative, plus copy u, take derivative of x, which is just 1. And now we plug that into the original equation, or rather in, perhaps if you want, into this equation. So let me copy that equation. Yeah, let me copy it. Copy, and I can paste it here. Okay, so what we have is u prime x, okay, plus 1 over x times ux, that is y, right? So what I'm going to do is, in each of these cases, I'm going to replace this y, and this y, and of course y prime, perhaps in a different color. The y prime, that is this replacement. Okay, keep going. That is x cubed, and then we have ux to the power 4. Okay, the x is cancelled here, and what we had here is u to the 4th, x to the 7th. Okay, And what does that now do? What we see, let's see what we have now. Did I copy this right? X to the fourth, y to the fourth. X to the fourth, x to the third, y to the fourth. Oh, yeah, okay, that's okay. Yeah, so okay. So what we have is u prime x plus u equals u to the fourth x to the seventh. Oh, okay. I'm stopping here because it's not working, right? You see, this is something I cannot separate. There are three terms here that normally you have one term on the left and one term on the right, right? And I cannot factor out anything. So what is the mistake I made? Of course, the mistake is here, right? There's a minus one. I forgot this minus one here. So there's a minus here. Now, how much does it make a difference? Okay, sorry, let me erase this here because it was wrong. So that's how you can see that you make a mistake, right? Because all of a sudden, the things that need to happen don't happen. So we have a minus sign here. Now you say, oh, what is that? So why is it negative x? No, be careful. What we have to do is exponentiate, right? So there's e ln y equals e minus ln x, which is, if you want, 1 over e ln x, which of course is 1 over x. And this, of course, is just y. So what we have is that y is 1 over x. Okay, so now in step 2, that's the special solution that we find. So this is the special homogeneous solution. Let me put a h now to indicate that it's not the original one, but it's a special solution. And so we know now that our form that we want is, y equals u times this homogeneous equation. So here u times 1 over x. That is what I want. Okay. So what does that mean now? That means that y prime is, let's take the derivative of the right-hand side, derivative of u, copy the second, plus copy u, take the derivative of the second, x to minus 1, that is minus x to the minus 2, right? Okay, so let's plug this. Now we can plug this in. So we have y prime is u prime 1 over x plus y over x, or let me write 1 over x times y, and y was u times 1 over x equals x cubed times u over x to the power 4. Oh, okay, sorry, I forgot to copy this part, right? So I forgot to copy something. Oh, sorry. So this here, let me do y prime, it's two terms, right? So it's u prime 1 over x minus u over x squared. Let's put it also in the denominator. Oh, that is much better news, because now I see that these two terms cancel. As I said, something has to cancel, because in general we need a left-hand side and a right-hand side, okay? Okay, so let's see, what is it now? What do we get? So let's work this out. This is x cubed u to the fourth x to the fourth. So this is actually u to the fourth over x. So cross multiply now, so we get u prime over u to the fourth is equal to x over x, which is just 1. Okay, that can happen. So if I write it with the du's, that is du, and here u to the minus fourth. Sorry, I don't want to make it sound as it's equal here, so let me go down here. So we have du, and then u to the minus fourth equals, and so this is just dx, right? So if I integrate, but now I'm integrating in general, so I need a general solution. So that I'm saying this so that I remind myself I need a constant here. So we get add 1 to the exponent divided by exponent equals, and the derivative of that is x plus a constant, let's call it k. Okay, bring the 3 to the other side, u minus cube equals x minus 3x minus 3k. We need to solve for u, so first of all, let's take the reciprocals of both sides, then it's u cubed is 1 over, and let's now call this c. So at some point, you make the constant simpler, but it might be sometimes you do it too quick, and then you say, oh, I have to actually call it something else, so, well, there are a lot of letters in the alphabet, so c minus 3x, okay, so I call minus 3k the new constant, and then the minus 3x goes there, so that is u cubed. Solving for u is just taking the cube root, so that is 1 over c, the cube root, c minus 3x. Is that the solution? No, don't box it, because that is just u. what we want is y. Remember, this is the actual form here. This is what we want here, this. So we see that y is equal to x over the cube root. No, wait. No, sorry, the x is in the denominator. The x is the denominator. Everything's in the denominator. 1 over x cube root of c minus 3x. That is our general solution. But however, it was an initial value problem. y1 equals a half. So let's go back into black. Step 3 or 4, I don't know where I am. Initial condition. So that if x is 1, then y was, what was it, 3? 1 over 2, a half. Good. So what you do, we'll just plug in. A half equals 1 over 1 cube root of c minus 3. Okay, take reciprocals of both sides. That means 2 equals the cube root of c minus 3. Let's take the cube of both sides. 8 is equal to c minus 3. And bring the 3 to the other side. We see that c is 11. So the final solution, the solution to the initial problem, value problem, is y equals 1 over x cube root 11 minus 3x. Okay, that's the form, that's a Bernoulli equation. So let's now look at one of the examples of the other type. What the book is somehow called homogeneous, but it's very confusing. It's not homogeneous in the sense that we are normally used to. So it's something of the form. So let me remind you what this is number 18. So the other form that we have is y prime is a function of just y over x. So in general, of course, y prime in a first order linear, in a first order differential equation, y prime is equal to an expression in y and x. But if somehow this expression in y and x is actually just an expression in y over x, then we can use the following technique. The technique is, what is the problem? So y prime is equal to y over x plus secant y over x. Okay, that's problem 18. There was no initial value here. So what is the first step we do? So step 1 is we look for the solution of the form u is y over x. Okay, so this y over x, this one single variable that is there, although it consists of y and x, that's why we just, it's basically almost a substitution method. Okay, so if that's the case, well, let's move on. It's perhaps fractions are always ugly to work with, especially if you take derivatives and so I write it this way. So y prime is equal to u prime x plus u x prime, which is just 1. And now we plug this into this equation, right? So we have u prime x plus u is equal to, now this is u and that is secant u. Okay? Here we can or cannot have, see, in this case it's actually not really necessary that these things cancel. It makes life much easier, of course. But if we, suppose this plus u would not have been here, this one, then we could still bring this to the other side by dividing. This doesn't depend on x. There's no mixed terms. That's why. Okay, but it is there. Otherwise, the integration would be horrible. So we would be stuck there. But in this case, we are fine. And now we separate the variables. We know that this is a separable equation. This has to be a separable equation. Otherwise, something went wrong. We saw that in the previous case, I got something went wrong there. Okay, so this means u prime over secant u. Wait, divided by secant u is 1 over cosine u. So that actually is cosine u, right? If you cross multiply, if you write it that way, it's much easier. Oh, no, I don't want to do that. U, just I can already do it here, right? Cosine u prime, or du perhaps, is equal to, and what do we have? 1 over x dx on that side. The x goes to the other, we have to divide by it. But I hope you understand all this little algebra, right? Okay, so we integrate. That's not so bad. The antiderivative of cosine is sine u equals, and that is ln of x plus c. But here we need now, this is the general solution. So this is we're going to find a general solution of this type. So we need the plus c here. Okay? What we need is remember, this is the actual solution. This is what y looks like. It's u times x. We found u. We still have to plug back in, substitute back in. So we better be able to solve for u. Luckily, this is not so hard. We have to get inside the sign, and in other words, you use the inverse sine function, which is often called sine. It's denoted sine minus 1, which is very confusing because it sounds like it's cosecant, which is not. And therefore, I just take arc sine. So u is arc sine. I'm taking arc sine on both sides, ln x plus c. Okay, so what is y then? Well, y is, remember, u times x, this times x. X arc sine ln x plus c. That's the solution. And you see, these are kind of ugly solutions, right? This type of function, with regular integration, if Calc 2, you would get ugly things, but if you look back, you never get really things so complicated like this. Here, these things get really complicated, solutions that you can get. Okay, and you can always check, of course. You can take derivatives of this thing. That is something that takes a little bit of work, but it's not so hard, and therefore you can check that you get the right answer. Well, you have to take the derivative of arc sine, and that you have to kind of remember how that works. And so it's a bit tricky to actually verify that you get what it's supposed to be getting. But I'm not going to do that. Okay.